So what exactly is GIS? GIS, of course, stands for Geographic Information Systems. Those right in the email. You didn't need to come to hear me say that. One of the big reasons people use geographic information systems is because it can store and query spatial data. You can do some pretty cool things inside of SQL and inside of these GIS tools that you really can't do with what we would normally think is stuff that goes in a database, like text and numbers and all that fun mumbo-jumbo that businesses really care about. And it lastly gives us the ability to attach geospatial data to pieces of data we normally don't think are geospatial. I'll get to that in a second. So basic GIS concepts. So when we talk about GIS data, we really have two different types of data. We have this vector data and we have this raster data that goes into a database. The names are pretty self-explanatory. Vector data is kind of what you would find inside an SVG. It's some sort of mathematical formula that shows you how to draw a line or a polygon or even three-dimensional shapes. Raster data, on the other hand, is a little bit interesting. When you see a satellite photo, or when scientists use satellites to take temperature readings of the surface of the Earth, those are typically raster types of data. They're very much like bitmaps, except instead of the bits representing colors, they represent some sort of measurement. So we have a project at Temple University that measures aerosol optical density, how much stuff is floating around in the air. And so we have these raster files where for each pixel, we have maybe 10 or 15 different measurements of how reflective the surface is, of the temperature of the surface, and other readings like that. So we have these two basic data types that we're working with in a database format. Yes. Cool. So why would someone use GIS? Well, we now have this concept of a geospatial query, an ability to run queries inside of SQL that will do math on spaces for us. We can do measurement type of queries. How much space is something occupied? How far is it away from somewhere else? Where is the middle of this object? Do these two objects overlap? So we can now kind of ask SQL type questions about pieces of data that have shapes to them. We can also use it to create graphical representations. All the weather maps you've ever seen, traffic maps you've seen, those are all GIS generated. Somewhere there's some sort of raster background, like Google Earth or something of that sort, and they overlay data onto it. This data isn't created by some graphical artist who sits around Photoshop all day. It's automatically generated from some sort of GIS data system. It's very important for the municipalities. They use it a lot to track physical infrastructure. We're lucky to be in the US, even though we restrict the hell out of your rights. One of the things we do is we turn around and give you maps. So I hope you like your trade-off. Most city, local city, state, and of course the federal government put out tons of free mapping data. This stuff is all over the place. So you can do all kinds of neat stuff with it. And not to mention we have organizations like Google and Yahoo who put all kinds of free stuff up for us to also play with that we can overlay things onto or steal for our own use. So now we've kind of heard a little bit of an abstract of what GIS data is and what we use, or what we use it for. So when we want to, go, hey, I want to do something with GIS, well, what exactly do you Google? What forms does GIS take in software? There's a couple standards, and there's several different packages of software built on those standards. One of those organizations who puts out these standards is ESRI, and they're very well known for the shapefile. Anytime you go to a local government website, or anytime you go to our federal government website, you will most likely find the data inside the shapefile. It's a very well-known data type, and it's a very common data type, and it's a very reasonably compact data type. So if you want to obtain GIS data, looking for shapefiles is a good way to find it. And then we have the Open Geospatial Consortium. They've come up with a lot of really cool things. Two of the biggest contributions they've made are WMS and WFS. Web mapping services and web feature services, respectively. These are really kind of the crux of GIS when you think of mapping, especially when you think of internet mapping. A WMS is a RESTful type of web service where you send some sort of GET request via HTTP, and you might say something like, show me these layers inside of this bounding box. I want to see the U.S. overlaid with a roadmap and, I don't know, something else goofy, the capitals. So WMS would go off in the background, grab some geospatial data, create some sort of display in whatever format you ask for it in, whether it be PNG or PDF or something else, and send it back to your browser. This is pretty much how Google Maps and how Yahoo work. You can query these maps without necessarily using their web front end. So WMS is pretty cool. It also gives you the ability to use other people's maps. So not everybody wants to build their own map, but a lot of people like to build their own overlays. Show me the areas where I'm gaining in business. Show me the areas where I'm losing in business. Show me areas that are getting hotter because of global warming. Or show me areas that are getting colder because it's a conspiracy theory, whatever. You're interested in the overlay, not necessarily the underlying data. Well, WMS allows you to take somebody else's map and stick your own stuff on top of it. Or take somebody else's overlay and add that to yours as well. WMS really allows you to kind of pick and choose from other people's maps and take whatever layers that you want from them. And there's several free WMS services out there. Microsoft runs one. Well, a lot of NOAA runs a few. And there's a few other government agencies that run these WMS services that you can load up in a WMS browser and just kind of go through. The other standard I mentioned was WFS. This is, I'll answer your question before I move on. What's up?
I'm sorry, I just wanted to verify. Is this services obtained through a satellite, you said, or through like municipalities or whatnot?
What do you mean by these services?
The data obtained and the WMS servers.
WMS is merely a web-friendly way of transmitting this data. The collection of the data happens several ways. Some governments collect it via satellite surveying. Other entities do it through, putting a man on the field and actually doing surveying and drawing up maps. The data is collected a various number of ways. I really don't cover how it's collected. I cover what we do with it once it's electronic. And WMS is a much more friendly way than emailing around shape files or however else you feel like shipping them around.
So you don't actually write the software that manipulates the data?
You can. I'm a bit unclear on your question.
You mean the raw data or the processed data that's now served via WMS? Because I get the sense that there's the raw data, and then someone like NOAA would produce a WMS.
I think it's where you're going with that. So when you acquire data through WMS, typically you're asking for a display of data. Right? WMS returns something like a JPEG or a PNG. That's not something that you would necessarily turn on and feed into a database. It's been produced from some sort of raw data. So it's only good for visual displays. If you were to turn around and feed that to a database, you get some really, really interesting results. Shape files are very good for transmitting raw data. Actually, I should clarify, shape files are very good for transmitting vector data. If you want to do, let's say, transmit raster data, there's something called a GeoTIFF. It's a TIFF image with some special headers that give it some geolocation. When you look at this TIFF file, this is the projection you're going to use. This is the type of mapping we use. And this is the space on the surface of the Earth that you can expect to find this. So far we have shape files and GeoTIFF store raw data. And WMS and WFS serve that out for our consumption, typically visually. Good. Okay, cool. Yes, thank you. WFS is web feature services. It is to rasters what WMS is to vector data. Yeah? Oh, you were going to ask something, I'm sorry.
No, just had it itch.
So WMS is typically used for serving out vector data. think of Google Maps looking at a street. When you want to add an underlay to it, when you want to add, you actually want to see the surface of the Earth, or you actually do want some sort of temperature map, you would use WFS. WFS will give you a visual representation of raster data. So it's not that fun. Not a whole lot of people use it. You find WMS much more commonly. Yes.
So in other words, like if you wanted to ask someone for a map with vector data of like rivers or roads of a municipality, then you also wanted to overlay like elevation or income level or something like that, you would actually talk to a WMS and a WMS server, and then you would be responsible for compositing those somehow?
The client would be responsible for that. So that happens a couple different ways. Just like with a lot of different applications, we have the concept of thick applications that live on your desktop and of web applications that live in your browser. There do exist JavaScript libraries, which I'll get to later on, that can do that for you, so that a user can just kind of pull up a website and it pulls them both down. Thick client applications can do the same thing, but the point is that yes, it's the end user's machine that's responsible for requesting both layers and putting them on top of each other in some sort of same manner. All right.
Jeff, it sounds like something from Roman Warren's Dr. Fowler.
I've never had Dr. Fowler. No. I'm ISMT, not CIS.
I have him now. He's my pet. Dr. O'Fallon. So he should.
What?
Who'd you say was it?
Dr. Fowler?
Yeah, he's my math concepts. It's like discrete math. I have him right now.
He teaches that.
He's quite an interesting character.
They all are. Oh no, I know who LaFawn is. That guy's a nut job. I like him. Anyway, so now we know kind of abstractly what this GIS data is. We've talked about a few ways to store it and to communicate it. So what actual tools do you use to carry out these functions? Well, there's several out there. Going from the back end and working our way to the front end, there are several different tools we use to store GIS stuff. I already talked about the shapefile, so that's not up here. And that's not really any fun. You can't really query a shapefile. Microsoft SQL 2008 handles it, and so does Oracle. Oracle actually has really good GIS support from what I've read. But since we're all a Linux users group, we're interested in the open source stuff. And the by far most powerful GIS backend right now is PostGIS. It's a Postgre database server with a GIS plugin. This GIS plugin more or less introduces some server-side functions. Like if you want to calculate the distance between two geometries, there's a function you can put right in the query and get either some sort of numeric output or get some sort of a binary true or false output. It also gives the database a way to very quickly index these geometries. Obviously, indexing text and indexing numbers is a very kind of logical thing, but when you get to indexing geospatial data, when you get to indexing rasters, when you get to indexing vectors, it becomes very kind of, all of a sudden is not as trivial as it used to be. So PostGIS has very good support for giving you very, very fast queries and for giving you a good library. I didn't put it on here because I don't recommend it, but MySQL is also currently working on a GIS plugin, but it really stinks. They don't follow very many of the standards. They don't have very many functions, and this in part is because they're worried about raw query performance, and they haven't figured out how to, I guess, gracefully handle this data in a blindly fast speed.
So that's like pretty consistent with MySQL in general, right? I've never heard of anything other than speed for the simplest stuff.
I've actually been very, very impressed with how fast PostGIS is. When I get to the demonstration, I'll show you some of the things that I've done with it and show you some of the query times. So now we have these shapefiles or these full database backends. However we receive data, how do we look at them? Obviously, we don't want to let them sit in our hard drive and just kind of waste space. So we have these GIS viewers. The most notable one you will probably hear in your office or around the internet is ArcGIS by, guess who? ESRI, the guys who invented the shapefile. It is extraordinarily expensive, but it is a really, really nice piece of software. I've heard from a few different graduate students in our department that it's very capable, very fast, and does a very good job. But of course, once again, we're the Linux users group. We don't really care too much about ArcGIS. So what do we Linuxites use? Quantum GIS. Quantum GIS is also a very, very capable viewer. It consumes WMS, it consumes WFS, it can consume directly from a PostGIS database server, and it can open up shape files and raster files directly. So when you think about viewing these items or testing overlays, this is really your Swiss Army knife for consuming geospatial data. So far we have where you store it, how you manipulate it. We have a front end for viewing it. And by the way, the front end can manipulate it too. If you enable it in your database, you can grab a geometry and drag it somewhere else, and it will turn around and update the back end, about the geometry's new location. Cool. So how do we serve over the web? Well, we talked about WMS and WFS a little bit, and we talked about ways to consume it. But we really didn't talk about ways to serve it out. There's a couple of popular tools for that. The first one, and I put it first, is absolutely my favorite, is GeoServer. It's an open source Java servlet that can read either from shapefiles or from a PostGIS backend, and you send it simple queries via HTTP as a GET request, and it will send you back visualized data in whatever format you want: PNG, JPEG, PDF, SVG, whatever you want. It's pretty cool. The next thing I put on my list was ArcGIS. Obviously, they can't make a client without making a server. That one I didn't find too much about. I also didn't look too hard, so they don't hold me responsible for that statement. And the last one is MapServer. MapServer is also kind of the same family as GeoServer. It's open source. It's not really that popular. So they're mostly kind of scraggly looking and scared me away. But it's also supposed to be a good way of serving out WMS and WFS data. All right, now's the part where I shut down the display again and try to break my way into my own network so I can show you some cool stuff. So now would be a good time for a 5 or 10 minute intermission.